In this video, we're going to see an example of a Variadic template. A Variadic template allows you to create functions that take an arbitrary number of parameters with arbitrary types. So we'll do a simple example. We'll write a function that will just print a bunch of stuff. So my function, I'm going to call it print, is going to have some first type and a first parameter. Then it's going to have the rest of the types. And first type and rest of types are just sequences of characters that are names. I could call it X and Y, T and K, whatever I want, I can name it that. These are just the ones that I chose because I wanted to demonstrate what they were. But this name and this name can be whatever I want. And then I need to follow the rest of types to indicate that there's multiple ones there with an ellipse. And I'll call those the leftovers. And you'll see why in a moment. Now I also need to indicate that first type and rest of types are type names. So I'll do that with this template call. And notice to indicate that it's a set of types, type name, rest type. So in my function, I'm going to do something with the first parameter, and then I'm going to make a recursive call with this parameter. So I'm going to see out first parameter, and then make a recursive call to leftovers. And again, I'm going to follow that with 3 periods to indicate that there's more than one thing there. Now I'm going to need a base case, and that base case is when I don't have any parameters left, and I'll print an end of line there. Now also, this needs to come before this so that when I get down here, it knows that there's a print function that takes no parameters. And to call this, I simply just need to say print, or actually, let me define some variables. And I'll print, and I'll just say hello world first. I can also print some numbers. And finally, I'll print XSD and then another string. Okay, so there's my print statements. So I don't think I've yet actually gotten one of these to compile the first time. So rest of types has not been declared. I was lazy here. And I need to make sure that that matches. I think it does. Yep. So let me save. If I print this out, notice it prints hello world, 1, 2, 3, 4, 5, and then all this stuff there, except that I misspelled folks. But that's a minor issue. Now this particular capability was introduced, I believe, in C++ 11. And certainly this isn't the most user-friendly function that we've done this semester, but C++ 17, we can actually write something that's even a little bit cleaner. Actually, before we talk about this, I don't think we actually talked about what goes on here. So essentially what's going on is, if you've ever used Scheme or Prolog or one of those languages that has a head and a tail in a list, that's essentially what's going on here. This is the head, this is the tail. And you do something with the head, and then you do a recursive call on the tail. This is very similar to how that works. If you haven't seen that before, think of this as a bunch of things. We take off the first one, and then we do the same thing to the rest of them. Now, when we've got the rest of those left over, now there's one fewer because we took off the thing that was at first, and then we make this recursive call, and we get a smaller and smaller list of arguments each time until ultimately we get to our base case where there's no arguments. Okay, so C++ 17 we have a new feature that lets us write even more compact Variadic templates. So I'm going to write a function called sum. And notice the ellipse comes before the type parameter here. And this is going to have to return auto because I don't know what type this is going to be. And I'm going to return x plus, and that's essentially all I need to do. I don't have to set up that recursive call. I just need to put the ellipse here and it says, oh, okay, I'm going to call this function recursively until I'm out of types. So let's compile that. Actually, let's also put some test code up before we look at that. So now let's sum some ints. And I'll do sum 1, 2, 3, 4, 5, 6, and for good luck, I'll also do x. I can also sum doubles, and there I'll do 9.99, 3.421, 1, 2, 3, and just to show you that we can do this with variables as well, I'll do d. So let's compile this. Oh, I got an extraneous 3 here. And if I run this, you can see that I don't get any output. Yes, I do. I didn't put inlines here correctly. So again, before you start to debug, always make sure that you actually have a bug in your code. So let's compile, let's run, and there's our sum. Okay, so that's a quick introduction to Variadic templates. There's a lot more here, but this is good enough for you to grasp for now.